All right, so this is the second video on this, and I wanted to change it a little bit just to give you a little bit more insight on what these graphs can do and how it kind of tells a story. All right, so for instance, right now, what I'm going to do is I'm going to start this guy at a different location. So I'm going to start him over here. All right, then we're going to pause. We're going to, no, I don't want to reset everything. Cancel. There we go. All right. So we're starting at about 8 meters. All right, so right down here. So at time 0, he's going to be starting down there. So we see the starting location was at -8 meters approximately, right where the tree is. Now he's heading back towards the origin, which is 0, 0. He's going at 2 meters per second, constant positive velocity. Now he went past the origin and continues to move. But let's say, oh no, he forgot his keys or his wallet or his phone sitting back there. All right, and so he sits for a moment, checks his pocket, and wonders, okay, where is it? Sits there, it looks cool, and then says, oh, I left it back in the tree. So I'm going to hightail it back. We'll do a little bit slower. And it starts moving back in that direction. So now we see he was moving at a constant velocity away. And then he stopped to think. There's 0 velocity, so it's flat on the position time graph. It's at 0 on a velocity time graph. Then he heads back to the left, right? This is a negative slope, so we got a negative velocity, right? This, what you would calculate on this slope would equal, 4, and it's in the negative direction, so it'll be -4. All right, so I get back here, and then I realize I'm going to be late. I got to get to my house. All right, they take, let's say, a second or two to pick up the phone, and then decides to hightail it back to the house. All right, so he's getting there. He's right about at the origin now. Now he's heading back towards the house, and he gets there. All right, then he just sits and hangs at the house, not moving, etc. So what I wanted to show you is a little different than the first video, which just my starting point is different. So what my y-intercept would be. So at time 0, whatever that initial starting point be, it could be anything along this line. It could be at the origin at 0. It could be at 10 meters. It could be at 1,000 meters. Doesn't matter. But that's the starting point. That's telling you its location. So if it's a negative value, it's not telling you it's less than or anything. It's simply telling you, oh, it's to the left or in the negative direction from the origin. In this case, that's left. All right, so it started at 8 meters to the left of our origin, our 0 point. All right, and then we can see here that now it's moving in the positive direction. This is a positive slope, which tells me it's a positive velocity. So it's above the 0 and it's constant. A line is going to be constant. Again, you do not need to connect the lines. So this part and this part and this part and that part could all be gone. So it's just horizontal dashes, it looks like. That's totally fine, acceptable. All right, so here it tells me I'm moving. I go past the 0 points, and then at about the 5-meter mark, I stop, and I'm not moving for a little bit. And then I turn around. I'm heading back towards the origin. I keep going past the origin. All right, then I stop back where I started for a couple seconds, or less than that, half a second. And then I go a lot faster now because I have a steeper slope than either of these lines. I'm moving faster, and I'm moving in the positive direction. I go past 0, and then I get to my house, and I'm at 0. So now we can do a playback and kind of follow the movement of this person with the actual graph. So you can take a look and see here. All right, I'm moving to the right. I got a constant velocity that I see here. My position's telling me I'm moving to the right. Here's the origin, and I keep going. And then I forget that I left my phone back at the tree, and so I stop for a second. All right, so I have no change in position, so I have no velocity. And then I'm moving back into the left a little bit faster now, so I got a little steeper slope. It's a little bit below, and I'm moving left, so it's 0, not moving again. Now I'm moving back to the right, but I'm moving faster. So you see it goes up on my velocity time graph a little bit higher because it means I got a faster velocity. Then I reach my destination, and I'm not moving. My position doesn't change. All right, so being able to explain that, understand it, you'd want to get to a point where we could see this movement of the person and then kind of draw in each of these. All right, so they're going to be straight lines at angles. They're going to be positive, moving in the positive direction. Flat, they're not moving, or have a negative slope, they're moving in the negative direction. All right, so, and then there's just going to be lines, no connections on your velocity time graph. So this is all we need to worry about for this unit. And so trying to explain it and follow along why this is the way it is really, really helpful. All right, so hopefully each of these, this one just had a different starting point, and we walk through the motion and what it looks like on a position time versus velocity time graph. Take a look at these, practice them out. You can try different scenarios in your head. You can look up different graphs and then try to explain the movement that's going on. Position time graph is the only one that's going to necessarily tell me that I started 8 meters behind the origin. Velocity time graph can't really tell me that. And so this one tells me a little bit more information, but I'd have to do some calculations to get this stuff. All right. Hopefully that helped. Let me know if you guys have any questions.